Hi everyone, good morning, good evening. Hope you all are doing well. My name is Mayank Aggarwal and I am a senior software engineer at CG Infinity. And today I'll be diving deep into the topic of accelerating enterprise technology with Internet of Things. So I'll also be giving some live demos for better understanding and more clarity on this topic. So stay tuned for that. After the session, in case if you have any doubts or queries, then feel free to reach out to me via LinkedIn. This is my LinkedIn profile. I'll be more than happy to help you out. So let's get started. So when we talk about enterprise applications, these are some of the big names that come to our mind. For example, in CRM we have got Salesforce, in ERP we have got Oracle, in project management we have got Jira. There are a couple of more. The list is endless. I only included a couple of them here, but these are the most widely used tools across the globe in an enterprise while building their IT infrastructure. So now let's understand the why behind this integration, like why an enterprise would want to integrate IoT with their existing IT systems, or what are the benefits or advantages they are going to get from this integration. So let's discuss about that. So the biggest limitation of a software application or an enterprise application is that they cannot interact with the physical world standalone. For example, if I want an application to monitor the performance and health of a machine by tracking its temperature, then that will not be possible without integrating IoT device with our application. We will have to integrate some kind of sensor or actuator with our application in order to get this thing done. So with the help of this integration, we will be able to automate, or we will be able to make our applications interact with the physical world and automate some of the processes related to the physical world which cannot be possible uh, with enterprise apps or software applications standalone. So with this improved automation of processes, manual effort will be reduced. This is one of the biggest advantages. Also, we are going to have a better collection of data which is going to improve data analytics and forecasting processes, and with that we'll be able to provide a better user experience or a better customer experience, and all these things will contribute to streamlining business processes with increased profits. Now, there are some of the myths that an enterprise has in their mind. These are some of the myths that I have noticed, which are there in an enterprise when they think of moving towards any evolving technology like AI or IoT. So, some of the myths that I have observed are, one of them is that whether they'll be able to utilize their legacy or the existing systems. An enterprise think that they will have to move towards new systems in order to integrate their systems with IoT, but that's not the case. We'll be seeing this thing in the demo. Also, they, like, another myth they have is that it's going to be a big change in their IT infrastructure, like too many modifications in their existing functionalities will be needed, which is again not the case. So we'll be discussing that also. And then high maintenance effort will be needed. This is a myth actually. Depending upon the complexity of the system, maintenance effort will be needed, but it's not that high. Like it only depends on the complexity. If the system is simple, if the system architecture is not that complex, then the maintenance effort will be low, and depending upon the system architecture's complexity, maintenance effort will increase. Now let's bust these myths and let's understand all these things with a demo. So for this demo, what I have done is I have created a small smart energy meter as an IoT system just for this demo by using a Node MCU, which is a Wi-Fi enabled microcontroller unit, and a current sensor which is going to measure the current across the load. So what this system does is it just measures the current and sends it to Node MCU, and this Node MCU sends it to cloud or to different applications based on how I have programmed it. So let me just show you that, and let's switch to the demo. So this is how the smart energy meter which I created looks like. This is the node MCU microcontroller unit. This is the current sensor. This current sensor is going to measure the current across the load and will send it to node MCU for processing. So I have integrated the smart energy meter or miniature smart energy meter circuit with three applications. One is Salesforce, second is Slack, and third is Azure DevOps for different purposes. I'll tell you what those purposes are. So I'm considering an example of retail energy enterprise for this demo, where this since we are dealing with smart energy meter here. So let's see the Salesforce integration part first. So in Salesforce, what happens is this is my Salesforce org, and what it does, what our smart energy meter does is, like, whatever data is being uh, whatever data is being calculated by the current sensor, that data is sent to Salesforce and stored in Salesforce over here in this usage object which I created. And this happens with the help of an API which I created. I'll show you how, like, what was the coding part done both on the node MCU and on the Salesforce side in order to integrate these two systems. But let's first see this in action. So currently I have connected this system or circuit to power, and now whatever data, let me just refresh it, whatever data is being collected by current sensor, that is being passed to Salesforce. Like you can see here, some new readings are coming up. Whenever there's a new data, there's a new record created in this usage object. So now we have 534, now we have 538. So these values are coming from the this current sensor only and are getting stored in the Salesforce org. So let me just open one of the usage record just for more clarity. So this is the usage value and this is the account name. The account is for now my account only. Now let me just show you the coding part for node MCU which was done in order to send this data to Salesforce org. So this is the code snippet which is responsible for sending this data to our Salesforce org from node MCU. This is the same code which is currently running in this system in my node MCU controller. And this is the code responsible for sending the data to Salesforce. So what it does is, I created a Salesforce get API or REST resource class, and our node MCU makes a get API call to that class or to that API. This is the endpoint of that API, and passes the value which is being recorded by our current sensor. And then Salesforce, whenever this endpoint is hit, Salesforce gets that data present in this value variable and stores it in Salesforce. So this is the endpoint of my API, services slash apex slash usage. This is the base URL host of my Salesforce org, which is this. Uh, and then, so whenever there's a value, like whenever there's a value greater than 40, I'll tell you what is the significance of this check of greater than 40. Whenever there's a value greater than 40, our an API call is done from our node MCU to Salesforce API, where this URL is hit, this endpoint, and this is the host with bypassing all the authorization headers. And yeah, now let's go to the Salesforce side. So this is the API, or this is the REST resource class which is being called whenever this endpoint is hit. This is the same endpoint slash usage which is there in the code. Now, whenever this endpoint is hit over here, this class is invoked, usage history class, and this method is called insert usage. Now we are declaring over here request and response variables, and whatever value is being passed over here in this after the usage slash, that value is collected and stored in the string value variable, and then a new object is initialized for Salesforce, and then in that account name is hard coded as my name, and then usage value is being passed as the value which is coming in this variable. So this is how our system is working right now. This is how these two things, with the help of by doing these two things only, I was able to integrate my smart energy meter with my Salesforce org. Now let's come to a use case where there's a, let's say there's a failure in this smart energy meter. There's a hardware failure, not a software failure, and I want to send a message on my Slack group and log a ticket for the support team in my Azure DevOps instance in case of failure. So in that case, uh, I have used couple of more APIs of Slack and Azure DevOps in order to do that thing. So let me just show you that first of all. Okay, so this is my Slack channel. Now let's say if there's a failure and I want a message to be posted over here that there's a failure here. So in order to create a situation of failure, I'll just remove this current sensor, because so I have just removed this current sensor. Now since this is a situation of failure, I should get a message here. So I have got a message of current sensor failure here. And now I need a support ticket. I need a ticket to be logged in my ADO instance for support teams in order to monitor that thing and in order to start working on that failure. So let me just refresh my page. So we have got a ticket created. So these are the two integrations other than Salesforce that I have done for the smart energy meter. So let me just show you how on the back end how the processes are working for these two integrations. Let's start with the Slack first. So now for Slack also I am using Slack APIs. I created a small app I just enabled I did some configuration changes on the Slack API side where I enabled this incoming webhooks, and I just installed this alert app in my channel, this IoT channel for Slack which I created, and with the help of these webhook URLs, uh, I am able to invoke this. I'm able to make an API call and I'm able to push a message to my Slack channel with the help of an API call. So let me just show you how the code on the Node MCU side looks like. So this is the significance of our check value less than 40. So whenever there is a hardware failure, our analog reading will drop down below 40. So that's why I've added this check just to identify the failure, so that I can predict, like I can identify that if the value is less than 40, then it's a failure. So now what I'm doing over here is I am again calling the Slack API. This is the Slack host and this is the Slack URL or endpoint which I got by doing those configuration changes on the Slack API side. I have passed this endpoint and URL over here, and now this is a post API call. So whenever there is a failure, which means value is less than 40 and is message sent is not equal to true, which means I am using a flag here for is message sent, just to check that whether the message has been sent to my Slack channel only once or not. So whenever there is a failure, which means value is less than 40, this is the Slack URI, this is the Slack host which is being invoked, which is being called from my Node MCU. Again, an API call out from my Node MCU in order to publish a message to this Slack channel. So now this was the Slack part. Now let's discuss about the ADO part. So what I have done is, let's move on to ADO. So in ADO, Microsoft has provided the APIs for ADO work items, and I am also utilizing those APIs only in order to create work items in case of any failures, just like this happened. So these are the APIs provided by Microsoft, and these are the Azure APIs, and I am calling this API with this request payload and couple of authorization headers to create a work item in my ADO instance. So this is the Postman. I'm showing this in the Postman. Let me just show you in the code. So This is the ADO URI which I am seeing, which I have added over here. This is the host base URL which I have, which we need to provide dev.azure.com. This is the ADO instance name. Uh, this is my ADO instance name. This should match, and this is the project name, integration project name, which should match over here. So in whichever project you want to create a support ticket, or a ticket for this kind of failure, you can specify that ticket, that project name over there in the code. And this is the hard coded URL, which we have to provide. This is the host. So whenever there's a failure, it's going to create a support ticket here. It's going to make an API call out to this ADO URI and ADO host with the authorization header and this request payload, uh, where the message where the title of the case is current sensor failure. So this is how these systems have been integrated with each other. So let's have a look at the architecture diagrams of these three integrations. So this is how they look like. So as you have seen, we have, with the help of APIs, we were able to integrate our IoT device with our software applications, and with minimal or no code changes in the existing functionalities, we were able to integrate them, and not too much of an effort on the coding side. So yeah, by introducing a layer of middleware in between, we can easily integrate our existing enterprise or in general software systems with our upcoming IoT systems that can help us in improving our business processes. So let's go back to the myth slide just to ensure that we have covered all of them. So we were able to integrate our IoT device with our existing systems of Salesforce, Slack, and ADO, with not a big change in the infrastructure, or no existing functionalities were tempered during the change. So it was just the new pieces of code that were added, and new functionalities were added in the system, and not high maintenance effort will be needed on the software side of the things. A bit of a maintenance will be required on the hardware side of the things. So yeah, that's how we saw how we can integrate our enterprise applications with our IoT systems. So that's it from my side for today. Thank you so much, and feel free to let me know, reach out to me over LinkedIn if you have any questions. Have a good day. Thank you.